So I think we're going to start. Hi, everyone. My name is Henrik Hartmann from the International Tree Mortality Network. I'm happy to welcome you to the Tree Mortality webinar number 12. Andreas Bolte will give a presentation. But before we start, I wanted to, oops, now it's not moving. Sorry for that. Here we go. I wanted to do an announcement. So as you know, the Tree Mortality Network, we're aiming to provide data on tree mortality across the globe. And since a couple of weeks, we actually have published on our webpage the first open database, open access database on tree mortality events. So please follow that link and you will get access to that database. So as usual, the presentation will be as long as Andreas will need. Usually we had sort of 45 minutes for the speaker, but it's up to Andreas. And then we follow with a question and answer period of about 15 minutes. For this, please use the Q&A function and not the chat. The Q&A function you fit at the bottom of your screen. If there is any technical difficulties, please use the chat to let us know whether the sound is not correct or something like this. And if your question is not selected, we apologize, but sometimes we have too many questions. We try to sort of bundle them into similar topics. So with this, we welcome Andreas. He is the head of the Thünen Institute of Forest Ecosystem, and he shattered the nice world of German forestry, I think last year, 2 years ago, when he published sort of like this graph that you see at the top half, showing exponentially increasing mortality rates in the German forests. And this is what his talk is also about. So forest mortality dynamics in Germany, how can we cope with this? So thank you very much, Andreas, for being with us, and the floor is yours.
Yes, thank you, Henrik, and hello to everybody. It's a nice pleasure. It's for me also, and thank for the organizers for giving me the possibility to give this talk. Yes, I will try to share my screen, and I hope you can see the first slide. I changed a bit the title, Forest Mortality Dynamics in Germany and perhaps beyond. So I will also present some slides from Central Europe and Europe to compare the situation with the situation what we have or recently had in Germany, and how can we cope. So the idea is not only for me, because I'm also a kind of a silviculturist, to discuss about the ways out of the, I would say, mortality tragedy, what we have to face in the moment. It's not only my talk, but also a talk together with my co-author, Tanja Sanders, and she works also in the field of forest monitoring, forest mortality, and she contributed also some slides to the talk. So let's start with the outline. I would like to present the beginning some data or facts about the forest damage in the last years from 2018 to 2021. Henrik already presented one graph. I will do it again also in a few minutes. But I would like also then to discuss with you about adaptive potentials of forest to environmental change impacts, and would like to suggest or present the idea of adaptive forest management to achieve in future more resilient forest, less susceptible to extreme events than those what we have in the moment. And would like to end with some conclusions and key message, and this might be also a basis for a discussion about the talk, what I've presented. Yeah, forest in Germany. If you think about forests in Germany, it's important to know that we have four major tree species, which is Norway spruce and Scots pine as coniferous species, and European beech and oak as deciduous tree species. But I will focus mainly on the two major tree species, one major coniferous species, which is Norway spruce, Picea abies, and Norway spruce is by far the most abundant tree species, the most important tree species. About 1/4 of the forest area in Germany is covered with Norway spruce. The forest includes about 1/3 of the standing wood volume of all forests in Germany, and nearly 30% of the carbon storage. But this is, of course, the most important fact. More than half of the total logging volume comes from Norway spruce. So you can see that Norway spruce is something like the backbone of forest and timber industry. And large parts of the German timber industry is, that they need more or less a constant supply of spruce timber. And timber is used in Germany for wood buildings, roof buildings, for example, but also for pulp and paper and other purposes. So it's, of course, by far the most important economic tree species in Germany, what we have. And the other tree species I would like to focus is European beech. About 16% of the forest area nowadays is covered with European beech, 70% of the standing wood volume, and more than 20% of the carbon storage. So together, Norway spruce and European beech covers about 50% of the standing wood volume and nearly 50% of the carbon storage within the German forest. But European beech is by far the most important tree species from the perspective of the potential nature of vegetation, because without anthropogenic interventions, about 67% of the forest area in Germany would be covered with natural beech forest. So, and due to this, we have also since 20-30 years the dynamic or the development to transform a coniferous dominated forest into a more broadleaf forest, especially using underplantings of European beech to renaturalize the forest in Germany. But as you can see from the pictures, with both species, we had problems with the extreme years, 2018 to 2020. Of course, if you look on the forest area, much more with Norway spruce, but in the last years, especially in 19, 20, 21, we are observing also increased mortality and dieback, crown dieback of European beech. But I will come back to this later. There is a nice publication. There was a nice publication last year from also our colleagues here, Cornelius Senf and Hubert Seide, and they use remote sensing techniques to illustrate the driver within this extreme weather events or extreme years, 2018 to 2020, but also a few from the space on the forest disturbance and anomalies, and two informations can be get from it. In the above figures, you can see more or less the summer vapor pressure deficits anomalies in midsummer, July to August, compared to the long-term mean 1986 to 2015. And what you can see is that, especially in the center of Europe and Germany, but also Czech Republic, we had 3 times or even more than 4 times increased drought impact here in the case of the summer vapor pressure deficit. And exactly in the same areas, we had also we could observe forest disturbances, which is more or less looking from the space, from remote or detecting with remote sensing techniques, is an idea of an index of the canopy intactness or canopy cover here. And also here you can see up to 4 or 5 times increased disturbances compared to the long-term mean. So you can see that drought, drought effects or impact covers or matched quite well with the disturbance areas, and this includes also the idea that these disturbances were not due to different management practices in the areas, but more from the drought impact. So management was not primarily induced the disturbances, but the drought impacts or heat impacts. Yeah, but we were also able to analyze the ground mortality using our ICP Forest network, the European Forest Network, Forest Monitoring Network. And what you can see here is also from 2018 to 2020 plots of the ICP Forest. I think it's level 1 plots with an increased annual mortality also compared to the long-term mean. And it's a bit astonishing if you think on 2018, because especially also in Germany, you cannot see increased annual mortality, but this is due to the fact that the assessments were done in early summer. And in 2018, the drought started in late spring. So most of the mortalities in midsummer and late summer were then recorded in 2019 and also later than in 2020. But you can see that also in 2019 and 20, you have more or less also in the same areas, Germany, but also Czech Republic, Slovakia, also parts of northern Italy, this increased annual mortality compared to the long-term mean. And on the other hand, we were also able to calculate the long-term temporal dynamics and trends and compare the soil moisture anomaly, which is more or less indicated in the blue line and the trend in this dashed line. And on the other hand, more or less the annual mortality rate. And what you can see, and this is the case not only for Norway Spruce, as Picea and Fargus, European beech, that you have a quite consistent decrease of the soil moisture anomaly or soil moisture content of the soils. On the other hand, an increase of the annual mortality rate. So you can see you have different variations. That's quite clear. But the long-term trend of decreasing soil moisture is more or less matching with an increasing annual mortality rate. Yeah, now the view on Germany focusing on Germany. What you can see here is the driver, which is more or less for drought, the climatic water balance. What we have calculated for entire Germany, and the climatic water balance is the precipitation minus the potential evapotranspiration, and this is done for the growing season from April to September. And on the left side, you can see the long-term mean, 1991 to 2010, and you can see Germany is still divided in 2 parts, with the eastern part, the more dry eastern part, with strongly negative climatic water balance, and the western parts, especially in the higher elevated areas, the Black Forest, the Alps, Bavarian Forest, and so on, areas with a high surplus or positive climatic water balance. But if you compare this climatic water balance with the extreme years, and up to now, 2003 was seen as a centennial drought, you can see that entire more or less Germany has a strongly negative water balance, but it's interesting compared with 2018, when you can see that 2018 was by far more extreme than 2003, and 2019 and 20 similar severe than 2003. So we had 3 drought years in a row. And if you look also on the situation in the winter period, 18, 19, 19, 20, you will see that there was no refilling of the soil water storage. So in many parts in Germany, we had not only 3 drought years in a row, but a 3 years drought period starting in late spring 2018 and ending in autumn 2020. And this is, of course, a quite new situation, which has never happened before. But there was also another remarkable extreme event in many areas, especially in those in the high elevated area like the Harz Mountains, Thuringia Forest, and so on. We had a storm event in winter 2017, 2018, the Hurricane Frederica, for example, and this delivered breeding material for bark beetles. And in the following year, the Forest Service was not able to take out all of this breeding material due to logistic reasons. And this was one ingredient of the so-called, I would say, infestation or outbreak of bark beetle. And without it, we would not have such a severe situation in Germany. The second, then we had this 3-year drought, 2018, 2020, and this was more or less the first one on record what we have in Germany. And we had then also prolonged hot growing seasons, and together with this available breeding material, we got into a multiplied bark beetle populations all over, and they're spread all over Germany, especially in the areas where we had already this storm events, and this was more or less the same areas where we have a high proportion or share of coniferous pure spruce forest. So, and at the end, due to the drought, the Norway spruces were not able to produce resin, and the resin production is more or less the core defensive activity of the spruces, so they were not able to defend the bark beetles, and then we had this outbreak, and this, I would say, catastrophic outbreak in many parts in Germany. Yeah, and now the figure again, what was then the result? If you look on the mortality rate, and this is our results of the Forest Ground Condition Survey 2021, and you can see that the mortality rate on this about 420 plots in a 16 square kilometer grid throughout Germany. You can see that the mortality rate for all of the major tree species, spruce, pine, oak, and beech, ranged between 0 and 1%. But then all of a sudden in 2018 and 19 and 20, we got this very extreme peak here, and spruce reached a record high or mortality of 4.2%. And after the quite cold and wet year 2021, there's still a quite high mortality rate of 2.8. So that's also an indication that bark beetles are still expanding and causing mortality in Norway spruces, even if the weather conditions are not optimal for the bark beetles. Yeah, we had also a peak in Scots pine, but this is also decreasing. But the second interesting point here is that spruce and pine is decreasing the mortality rate, but oak and beech are increasing. And especially for beech, it's interesting that we have a quite longer or long-term mortality trend that we often have at first more or less a crown dieback then perhaps fungi and bark beetles are coming in, and then always sometimes the second, third year, you have more or less this decline and the final mortality of beech. And I'm quite sure that we will have to face also a high level mortality of beech also in the next years. And I would like to draw your attention to the figure on the bottom here, which shows the information about the damaged wood volume. This is from our colleagues from the statistic office, the Statis in Germany, and the solid black line shows the share of damaged wood to total logging. And you see you have different peaks here, and the peaks are always associated with long blue bars, and these are the proportion of storm damage. So you can see that these peaks here with a high amount and proportion of damaged wood was in the past associated with storms, like here, for example, this is the Hurricane Vivian in Wiebke. Here in 1999, it was Lothar. 2007, it was Kyrill, and even here in 2018, it was the Hurricane Friederike I already mentioned before. But then all of a sudden we have a complete different disturbance regime, because you see these record high share of damaged wood, and this is of course more than 70 million cubic meter, and this is for the first time not associated with storm events, but with insect outbreaks, with particular the bark beetle outbreaks. And it's interesting that you have not only one peak here, but more or less 3 years in a row with a nearly a record high share of damaged wood. So in total in 2020, we had 72% in total logging was due to insect attacks. And in 2021, we have even an increase to 81%. So insects are becoming more and more important in the disturbance regime, and I think this is also one sign or one indication also for the future. But on the other hand, storm will not disappear. So we have a surplus of the storms and the insect attacks. So this is a quite traumatic situation, I guess, what we have to face in future with disturbance and that mortality in Germany. Yeah, and here some information or the comparison with our neighbors in Europe. You can see that by far the highest amount of damaged wood was here in Germany, 171 million. Mainly, I would say 80–90% are spruce, but also Czech Republic has a very high record, 68 million, even more compared to the entire wood volume what they have in Czech Republic in the forest. But also Poland was affected, but interestingly more pine than spruce to the pine bark beetle here, but also Austria and also some other areas. In total, you can say for Central Europe, you can assess or estimate about 300 million cubic meter of damaged wood in the 3 years, 2018 to 2020, and for so 100 billion cubic meter per average per year. And for Germany, 60 million. This is of course more or less the long-term complete felling or felling volume, yearly or annual felling volume, what we have in Germany. So, but what you can also see that this high rate or high volume represents only 10% or even less of the total Norway spruce wood volume what we have in Germany. So 90% are still there. And for Germany, it's 15% or about 15%, so 85% are still there. So that's the important question, what we're doing. How can we adapt those forests, the 85% of spruce timber volume, to be less susceptible to future extreme events. So and then we should talk about the adaptive potential to environmental change impacts. So, and we cannot more or less switch from one year to another to a complete different forest structure. We just have to live with it, and we have to assess what are the risks with these forest composition and forest structure. So, in last year we published a projection of the risk status using the National Forest Inventory plots. What we have in total, there are about 60,000 plots. Here only are shown the normal grid, which is a 4 to 4 square kilometer grid. And we used not a very sophisticated projections of the climate, but we talk more or less with the forest practitioners, and we say, what do you assess? What is a problem? What might be a problem when you see that, or where do you think are the tree species at risk? And for Norway Spruce, it was quite easy to assess. It was more or less an altitude of 600 meters above sea level, because if you discuss with forest practitioners about their practices to defend or to help or to adapt the spruce forest, many of them say it doesn't make sense in the lower elevated area. We will lose the fight against the bark beetle. So, but if you then apply this indicator or these thresholds, you will see that about 70% or 2.2 million hectares of Norway spruce are more or less affected by these risks. And this is also more or less the case for the entire wood volume. If you look on European beech on the right side, it's a bit more sophisticated, and we used also a site indicator, and we're looking for sites which are assessed as dry sites or very dry sites, and the thresholds are an available soil water capacity of less than 90 millimeters per 1 meter soil depth. And if you look more or less on the numbers here, about 1/3 of the beech forest are at risk according to this assessment. And the sites are quite more scattered here, but you can see, for example, the loam and calcareous sites of the Swabian, Franconian Alp, and also here Hainich area and so on. Okay, but if you think about then to say, okay, we want to transform in the next decades, in the next 30 years until 2050, all of these risk forests, we need a forest transformation area of 95,000 hectares per year. And of course, today we have only a bit more than 20,000 hectares per year. So we need to increase at least 4 times the transformation area to achieve a forest transformation until 2050. And our colleagues of our Forest Economics Institute calculated the costs on a range between 13 and 43 billion euro. And large range is mainly dependent on the need to protect the forest against browsing by wild animals, roe and red deer. Yeah, but then there's a question, what are the possibilities if you think about adaptive forest? And one idea is really not to change the tree species, but look more or less on the intra-specific adaptive capacities. And in the last years, we did 2 extensive drought experiments also with Norway spruce, but also before with European beech. And we selected many different provenances or ecotypes, populations from different parts of the species range. And we applied an extreme drought, but not irrigating the plants in the greenhouse, and we're looking how and when they are dying. And we used an indicator from toxicology called LD50, which means the lethal dose, where 50% of the population is killed. And this was dependent then according to the lethal dose of drought in terms of soil water availability, in terms of field capacity. And if you compare the results, which is here the logistic regression here, the survival rate of all the Norway spruce provenance with those of European beech. The first thing is very striking, that according to this, the spruce seedlings were less drought sensitive than the beech seedlings. That's interesting because, you know, if you look on the adult trees, it's the opposite of the set, that Norway spruce is more susceptible to drought, but this is mainly due to the fact that you need also the impact of the bark beetles. So the adult trees are not primarily killed by drought, but they cannot defend to bark beetles. And for the seedlings, bark beetles are not and pathogens. They need a certain thickness of the stems to be able to use it as for breeding. Okay, so but the other point which is perhaps more interesting in terms of intra-annual adaptive potential is that the difference between the spruce provenances were quite small. So these LD50, so a higher LD50 value means that you're more drought susceptible, and the lower means that you have a higher drought tolerance. And what you can see here, that a German more higher elevated provenances has quite a low drought tolerance, and this is Saxonian provenance in the lowlands has a more higher tolerance, and also this more southern provenance is here from France, from the Massif Central. For the beeches, you have a quite larger differentiation. So this difference means often about 7 to 10 or even 14 days of later death due to drought of these provenance here from Crécy, is the lowland provenance in France, compared to this highland provenance or high elevated provenances here in Spain. So in general, very general, you can say that lowland provenances has a higher drought tolerance than highland or high elevated provenances or coming from high elevated origins, and southern more tolerant than northern or central ones. But this is a quite general, you have to look in detail. So this is more or less the adaptive potential in terms of survival. But we did also some analysis on the questions of growth reactions on drought or warming climate. And for this, my colleague Tanya Sanders analyzed provenance trial of adult trees, and she did she caught the tree and did a dendroecological analysis. I won't go into details, but based on a more or less the growth or the climate growth interactions, she projected the growth in the future. And the figure on the left side shows more or less the cumulative growth deviations in a projections period from 2012 to 2055 compared to the local provenance there. And it's interesting that on this moist side here with the warmer climate, all other provenances performed better than the origin provenance. And the opposite is the case on the dry side, except of this only provenance. Most of the other provenances performed worse compared to the local provenance. So on this indicate that, you know, you have a certain potential of drought adaptation by provenance selection, but it depends also on the site. So you have a site provenance or provenance or adaptive interaction of the different provenances. And this shows that it's very complicated and you need huge effort to find the right provenance for the right site. And you cannot just generalize more or less the result. And this is also the indication that especially these provenance trials has to be expanded also on many areas, not only in Germany, but also Europe or even beyond, to have a clear picture of what is more or less the best or the best matching provenance for future climates on the different sites. Yeah, but intra-specific adaptation is not the only point. We have to think also on the change of the forest management itself. One quite new idea, of course, coming more from the area of nature conservation, is the idea of adaptive management. And in the former years, we discussed in many groups also about the possibilities, the optional limitations of adaptive forest management, or short AFM, for future resilient forests. And perhaps if some of you may not be familiar with the term of management and silviculture, here are some definitions. So if you think about forest ecosystem adaptation, it's more than forest adaptation or tree adaptation, because ecosystems are complex and they are individually dependent on ecosystem vulnerability, resilience, and dynamic. So you have different levels from the tree level to the ecosystem level. And if you think about ecosystem adaptation, you have to include all elements of the ecosystem and the interaction of the ecosystems. Active adaptation is needed if passive natural adaptation is projected not to fulfill the future demands on ecosystem services. What is meant with this? It's quite clear that often, and this is also, I would say, one idea that nature knows it better. So that means that often natural processes leads to a perfect adaptation. But this is, of course, only true if you have a complete open system, and also the possibility of tree species to migrate through the landscape. And you have also then no, anthropogenic impacts or limitations of migration processes, also of all the other ecosystem processes. And this is not the case in many parts of the world. So active adaptation is, for example, needed to overcome spatial barriers, for example, settlement areas or highly agricultural areas where species with they cannot overcome these areas, and to expand, for example, to site areas where they would be perfectly adapted. Active adaptation has to address the environmental change, so the stressor, pressure, and of course, in particular, climate change, but not only. They should also look on the social, economic, and technical change. And altogether, this can be termed as global change. And it's important that adaptive forest management provides a dynamic management approach for future, for forest adaptation to this global change. And so it's clear it's not only climate change, but also the social, economic, and technical change. Yes, and if you summarize it, you come into such a idea of a cycle. So, and start with the site and the stand structure, which is more or less given, but variable due to climate change, and you can monitor and you could do science on it. But the question for the management is, what for you're managing? You should have management goals. So, and this is not only due to the goals of the owner, but also on stakeholders and the entire society. So, and for example, 50, 60 years ago, nobody had any idea that, for example, how important forests nowadays are as for carbon sequestration and for climate protection. This was not the goal in the past of the society, but now it's a goal. And in the future might be also other goals in addition. So it's important that you deal with this changing management goals. And then you have also changing management techniques. You have new interventions, a new kind of management techniques. You have new machineries, thinking of all the elements of digitalization and so on. And this is, of course, also a matter of science and progress. And this leads more or less to a changed biophysical structure, or biophysical condition site stand structure. But then after perhaps 10, 15, 20 years, you have to reassess it again because these conditions have changed here. You have perhaps new management goals, new machineries, new techniques, and so on. You have to adapt. So the idea or the traditional idea in forest, you say, I plant a tree or several trees and I wait for 100 years, not me, but more or less the kids or even the next generation, and then I have the forest. I think that has to be changed because we are now managing the changes, not the forest itself. And this is, of course, very important, and also a kind of education, because you need very well educated forest managers. You need more or less the money and the effort for it, and you need also open administrations for it. So I think it's a kind of a process for, I would say, that the next generations to follow it and to fulfill it. Yeah, and one, I think, interesting element of adaptive forest management is assisted migration. Assisted migration means that you help trees to migrate through the landscape on a regional, but also up to a continental scale. And often assisted migration is seen as the introduction of exotic tree species, but it starts much on a lower level, because what I'm discussing or presenting about the different variabilities of provenances, this is also a kind of assisted migration if you transfer provenances within the species range. Here's an example from North America, from colleagues of USDA forest or US forest. You can see that here Western larch is more or less transferred within their range, but you could do this in Germany, for example, with European beech. You can take European beech from southern France, from the Balcony, for example. And you would not see any changes in the forest structure because it's the same tree species, but it's perhaps more adaptive or more adaptive provenances from the south or from lower elevation. Then you have the possibility to extend the species range, which means, for example, thinking about Hungarian oak, which is now already present in the eastern part of Austria. You can take it also to Germany, to the southern part of Germany, for example, to expand the range, because now the site conditions are perfect, perhaps for Hungarian oak, for example. And last but not least, you can also use exotic tree species from remote areas or other continents, thinking about cedar, like Atlas cedar or Lebanon cedar or what else. And but it's important here to think about the pros and cons. I think this is the case for all. So how can we more integrate new floral elements, and trees are also new floral elements, exotic tree species, into the existing into the existing forest vegetation to avoid invasiveness of tree species, more or less than outcompeting the existing forest vegetation, and also looking on the interaction with other organisms which are important to keep the ecosystem integrity, soil organism, insects, and so on. So, but the ideas, especially, and this is more or less the link to adaptive forest management, to see forest management as managing species migration at landscape and regional scale. So with the adaptive forest management and with the cycle, it's more the question to be dynamic in terms, or temporal dynamic. And here it's more or less a spatial dynamic. And both is very much needed. We have a spatial dynamic in forest vegetation to be handled, and a temporal dynamic. And so in terms, I think future forest managers are more, species range manager than more or less just manager for a forest standard at local scale. And this is quite a new thinking that has to be more or less implemented also in education and also in the management strategies what we have on different levels. So now I come to the end, and I would like to draw some conclusions. The adaptation of forest to climate and environmental change is one of the key challenges. I hope I could convince you that, this is a generation task. But without forest adaptation, I guess we are not able to reach our ambitious climate protection goals, not only in Germany, in the EU, I think worldwide. So forest adaptation is a kind of a key element of climate protection. I guess I could also convince you that adaptive forest management, so managing the temporal but also the spatial dynamic, that they support forest transformation and forest adaptation to climate, societal, and technical change. So it's also important. It's completely clear that climate change is a very important, it's overwhelming issue, but we have also a social and technical change, and we have to include this also. So don't think only of climate change, but also on global change. Assisted migration can be a key element of adaptive forest management to increase forest adaptive potential to future growing conditions. And assisted migration, in my eyes, is also the migration of the magnitude or of the high number of possible tree species in their combination. So because at the end, it's very important not to end up in one very adaptive tree species, but in a mixture, to increase also the possibilities for adaptation, because you cannot foresee what new and additional pressures and pathogens will come in the future. So don't think about the super tree species, but always think about a mixture and the widening of the options of the tree species, and not only the tree species. So one thing is very important: international collaboration throughout Europe and beyond is needed to step from this traditional idea of local management of forest to what I said, a regional international management of species ranges. So we need, for example, provenance trials, and it has been also the case. We have international provenance, but this has to be expanded. We need also this combined with silvicultural trials, and all kind also of monitoring. Remote sensing will play a very important role. And we need also a good setup and a network of scientists and forest practitioners, because they have to apply new techniques, and they have to implement also trials, because it's very important that you not only have that you do not only have more or less information on 1 or 2 experimental plots, but also on a large variety of 100, 200 of trials, and this has to be run by forest practitioners. That cannot be done only by scientists. And last but not least, political action is needed on regional, national, and international scale. And Germany has already started, for example, to include forest adaptation incentives in the climate protection strategies. For example, the Climate Action Plan in Germany. But this has to be increased and internationalized. So it's very important because climate protection is a task for the globe, is a global task. But on the other hand, this is also in a certain way also forest adaptation or forest landscape adaptation. And with this, I would like to thank you for your attention, and I'm open to all your questions. Thank you.
Yeah, thank you, Andreas. This was highly stimulating. I really enjoyed also the management implications and the policy thoughts that you have on this, which I do think this is actually important to make science carry on into real world and make it have a difference. So we do have lots of questions, of which I asked the first one here from Martin Gutsch. Do you think that the needed transformation rate of 95,000 hectares per year can eventually be realistic, achievable due to the fact that nature is doing it the hard way itself, so to speak? The background regarding the question is that future forest composition has strong implications for growth and sequestration, etc. And I wonder what the conversion rate will be in long-term simulation runs, for example, until 2100.
Yeah, this is a good question, Martin. I think this is more or less like a model calculation, what is needed. And of course, it's very interesting if you look on the fate of this publication, because we published this, I guess, in May last year. And then it was picked up by our federal government, and it's now more or less one of the bases of the idea of giving incentives for forest transformation. So it was a quite successful in political consultancy sense. But of course, I don't think it's needed to reach, of course, 95,000 hectares every year. And we have to look also on the possibilities. So my idea is really to use natural adaptation as far as it's possible, but then also focus on the areas where we have problems with it. And especially with Norway spruce, you can observe that in many pure Norway spruce stands, you have a dense regeneration of Norway spruce. So this next generation is often going directly into more or less pure Norway spruce stands, and this could not be the goal, because after perhaps 20, 30 years, you have the same disaster then with the bark beetle outbreaks then. So, and there's also the idea of forest transformation, but this does not automatically mean that we wipe out all of the spruces, but to bring in other tree species as mixture. And so in case the problems what we have in Germany is not the spruce, but that we have pure spruce then. So all the forests were gone on a large area, perhaps 300,000 hectare, 400,000 hectare, and then it's very difficult to recover the forest, because the soils are dried out and you have all the problems with late frost and so on. So it's very important to have an additional element in these forests. So I would say forest transformation means not completely changing the entire structure of composition, but bringing in an additional element. And due to this, of course, this is a maximum what is needed if we want to transform all of the forest area. And I'm completely of your opinion to look on the different sides, what is more or less offered by nature regeneration, and then to look if we should add additional cultivated component.
Okay, thank you. The next question is from Jody Chakraborty, I hope I didn't massacre your name here. Immensely interesting results. So Norway Spruce will
Dave.
Norway Spruce will benefit less from assisted migration compared to beech for drought tolerance. We get an opposite trend when analyzing carbon stocks as a trade. Clearly, there is a trade-off which complicates management decisions.
Yeah, of course, this is one study, one result, and I have to confess also that we may not include the extreme or provenance at the extreme margin of the spruce range. This was more the case with the beeches, so there could be also some bias in the results. But in general, I guess if you only look on the survival, there is some indication that the interspecific adaptive capacity of the spruces are less than the beeches, because you find it also in other studies. But this not mean that there is no one, but you know, in terms of yeah, and this is according to the survival rate. If you look on other factors or goals, for example, capture carbon and so on, there might be also different. And Dave, I know also your publication. I would not please do not understand me wrong in the case that I say there is no intraspecific or no possibility to increase the adaptive potential by taking other provenances. But I would say if you compare Norway spruce with European beech, it's less for Norway spruce than for European beech.
Okay, thank you. Mike Perks, do you have any research on the potential value of mixing species within stands? In Scotland, we find that mixing productive conifer does not provide a drought resilience improvement. Single species stands are better adapted for drought, but mixed species stands can show a growth improvement.
Yeah, that's really a good and interesting question. Yeah, we did also some studies on beech spruce mixtures. I did it several years ago when I was at Göttingen University. And in a certain way, we found also a similar result that depends on the competition vigor of the different species. We found out, for example, that European beech in pure stands had a quite higher intraspecific competition than the interspecific competition if you mix European beech with Norway spruce. So that you can say that the beeches are growing much better in the vicinity of Norway spruce because the competitive vigor of Norway spruce is less than European beech. So, so you can say that for beech, is beech the strongest competitor? So if you mix beech with any other species, often you have a better growth performance. The question of drought tolerance, it's quite difficult, I guess, to assess. But so I guess this depends very much on the different sites and the mixtures you are, or the tree species you are mixing. I know that for European beech and Norway spruce, you have something like root stratification often reported, which means that the shallow rooting Norway spruce is more in the topsoil and the beeches are in the deeper soil. And there have been also some reports of hydraulic lift, but I have no clear opinion or I do not see a clear indication that there's a general trend that the mixtures are often always leading to better adaptation to drought extreme events. It's more in the case that you have with mixtures often a higher growth performance. And the other point is, if you think about the indirect drought impacts of pathogens. So then if, for example, all the spruces in the mixed stands are killed by the bark beetles, you have the beeches left and there's still a forest cover and a canopy. So the mixed effects are more, I would say, indirect effects, and perhaps often not a direct, I would say, a facilitation effect between the species.
Thank you. Thorsten Grams asked the question about the provenance with the side interaction of tree susceptibility to drought. Is the side effect limited to abiotic soil properties, or does soil microbiome also play a role?
Yeah, this could be the case, but we have no information about the soil biome. So I guess it could be, but we did not investigate it.
Okay. Nadine asked, won't a provenance adapt again to the climate where planted, so that the initial better drought response might be given up after some time in a more favorable climate?
Yeah, that is also a very interesting question, and not easy to answer. So of course, it's also the question a bit on the population level, but because you can look on adaptation or adaptive potential on a single tree level, and I guess there might be also something like acclimation or so on, that the trees are then developing more deeper roots and so on. The interesting point is then the adaptation on the population level, and especially for European beech is also the discussion, and I'm also not sure with it. Then perhaps if you stand tree mortality, that in every place you have also some single beeches which are drought tolerant, and when they are left, you have an evolutionary adaptation after 2 or 3 generations to a well-adapted stand. And this should be the case, otherwise you would not have these differences in the provenances, in the margins. So but the idea is perhaps on the other hand, if you think about forest management or forestry, to speed these adaptation processes by taking more or less these adapted provenances more for the southern range margins, to skip more or less this mortality process, which is more or less linked to the evolution. So evolution is always more or less linked to mortality of the less adapted individuals.
Thank you. More questions are coming in. For we're already beyond time, so I ask you 2 more. So Johannes Löhr asked, based on your provenance studies, I would choose the most drought-resistant provenance for my dry side. Many others would probably do so too. How do we avoid a homogenization of genetic variety within a species across Europe?
Yeah, this is also a good question, and if I could give an advice, I would not only recommend more or less the most adaptive or apparently most adaptive tree species, because then I guess we have the same problem what we have, for example, with a very homogeneous provenance structure what we have in Europe, in Norway Spruce, because, for example, in the Harz Mountains, we have a little spot of autochthonous material, but this was not used because it was less productive, but it was used in other provenance that was spread all of the over the Harz Mountains, and this might be also one case also for disturbances, because there were really also problems with acidification also in the past, in 1980s, 1990s, and now with the drought and the bark beetle. So I think it's very important to have this diversification also of different populations, and not to more or less homogenize everything. But on the other hand, what I've learned, I'm not a genetic expert, but it's interesting that, if you look on several traits like drought adaptation is only a very small part of the, or is responsible perhaps of the genome. So that means there might be still also several other parts of the genome which is not more or less affected by the selection to a certain trait. So because I have some ideas about genetic structure in European beech, and it's interesting that if you look on the northern part of Central Europe, which means more or less Germany up to southern Sweden, you will see that from the genetic perspective, it's a very poor genetic structure, because all this area has how do you call it, origin more or less only from during the Ice Age. You had the refugium, which was in Moravia, and all of the area was recolonized after the Ice Age, probably by only this very small refugium. And so you have a very small genetic differentiation compared, for example, to those in several parts of the Balkany. But on the other hand, if you look on the individuals in the flushing, you will see large differences from beech to beech. So that's also one indication, that I guess the genome of the trees are so huge and so differentiated that there might be also, it's really a question and a matter of science still to look how the selection of different traits will really influence genetic diversity of the tree species.
Okay, and one last question, Mirella Bellui. Could you please explain the causes of pine death? Should this also not be planted in the future?
Pine is really also Scots pine. That is really a very interesting species, but also very complicated. And this is also the case why we did not include in our more very rough risk estimation, European Scots pine, because there is a huge and interacting causes for pine death. So there might be abiotic reasons, but we have a huge number of different pathogens in pine. So different kinds of insects, needle-beating insects, but also bark beetles in pine. And this is, of course, also the case with oak, and this makes it quite complicated to identify a single or the right death cause for Scots pine, because there might be a large variety of causes for Scots pine and interacting causes. So for Norway spruce is quite clear. You have most of the case you have the bark beetles, the spruce bark beetles, and for European beech is often abiotic stress, then some secondary mortality causes, but of course the overwhelming effect are the heat and perhaps also sunburn on something like this, so abiotic. So this makes it quite easy for the both species, but for Scots pine is much more complicated.
Okay, so thank you very much, Andreas. There are still open questions, in particular regarding the methodology of the assessments that you presented. I'm pretty sure that if people address you this by email, then you will send them a response. I have several questions also, but we can talk about this in June. So yes, thank you very much.
You.
and
to all, I'm sorry that I cannot answer all the questions, but you are welcome to send me an email.
Great. So thank you very much. And thank you very much, everyone, for attending this very nice seminar, and see you the next time. Bye-bye.